Hello and welcome to the Cigar Tube Circuit Tester project. On your screen right now is the schematic of the Cigar Tube Circuit Tester, which will pop up throughout the entire video as a guide for you. This video is a companion to the Cigar Tube Circuit Tester project on mottbots.com in its written form, where you can get all the details of what parts you will need for this particular project, as well as the steps to create the breadboard prototype circuit, as well as all the steps that we will be going through on this video in written format. So you can go check that out at mottbots.com, and I will leave a link in the description below. That way it's easy for you to find out where this project is. Here I have the PCB board. I've already cut this one to size, but you can find what size PCB board this is in the parts list at mottbots.com for the Cigar Tube Circuit Test project. Right now I'm needing to figure out how much of this PCB board I need to cut off to be able to fit in the cigar tube. This is the cigar tube here. As you see, it doesn't matter what brand or what color or what type you get. It just needs to be able to hold the electronic components within it, preferably a plastic cigar tube like this one, because it's easier to work with. You don't want to be using a glass cigar tube, obviously. It needs to be durable and be able to manipulate, because we're going to be drilling holes in it later on in the video, and we need to be able to have a nice handle for our circuit tester. So that's what the cigar tube is for. So I'm going to be using a ruler to help guide me on where it is that I'm going to be scoring the board, and then I'm going to use a rotary tool to make the cut. When using a rotary tool, you need to be careful, take care, and be aware of what you're doing, because even these little rotary tools can hurt you if you're not careful. So please be careful when using one of these tools. You don't have to have a rotary tool to cut this. I've done this project before, and I just used the X-Acto knife to continually score where it is that I wanted to break off the board, and when I got deep enough into the cutting the board, I ended up just snapping it off. So either way, you can use whatever tool is available to you to be able to finish the job. So now our PCB board can fit in the tube. So now all we need to do is decide where we're going to put all of our components on the board. This is a very small board, so putting through-hole components on it's a bit of a challenge, but it's doable, and you just got to take your time. So first I need to take this label off of this cigar tube, because we won't need that. And then I'm going to make some marks or where I need to drill the holes in the cigar tube. I'm going to make the first mark at the very tip of the rounded end of the cigar tube, and this is where our probe is going to protrude through, and you will see that we will be using your typical office supplied paper clip for our probe, and we will be doing that later on in this video. Now I'm going to be making some marks on where I want the LEDs to be. I need the LEDs to be quite close to the opening of the tube because it's a little difficult to get any farther down the tube to be able to fit the board, the finished board with all the components on it, deeper inside the board and then have the LEDs poke out of the holes that you drill. So I need to try to get the holes as close as I can to the cap of the tube, and that's where I'm making the marks at here. I'm just trying to decide where I want the LEDs to go, and be sure that when you make these marks that they're at the correct distance based on where you're placing your LEDs onto the board, because I've made the mistake of drilling 2 holes for the LEDs and then the holes weren't wide enough for the 2 LEDs that were on the board to fit through, so I had to get another cigar tube and then re-drill the holes to get the correct spacing for the LEDs to protrude through the cigar tube from the inside. As you can see here, I'm just drilling the hole now. Okay, for this project, I'm going to be using 5mm diffused LEDs, one white and one red. And I need to get the correct sizing for the holes for the LEDs to be able to poke out from the inside of the tube, just enough to where the LEDs are exposed, but I don't want the holes to be too big. So the size drill bit I'll be using is a 3/16 drill bit, as you can see here. And I'll just go ahead and use that 3/16 drill bit to make the holes larger where the LEDs are going to be at. Now it's time to start deciding where to place the components on the PCB board. The marks I'm making here is where I want the LEDs to line up at. So where I'm starting at is with the LEDs, because I need to get the spacing just right for them to be able to protrude through the tube from the inside. So I need to get that spacing just right. So here's the schematic again on your screen, so we can compare between the schematic and the breadboard prototype circuit that we made through the instructions provided at mottbots.com. We'll be starting with the diode D1. So I'm going to go ahead and remove diode D1 from the breadboard, and we're going to transfer it to the printed circuit board. And then I need to bend the LEDs the way I need them to be able to place them through the holes of the PCB board. So remember, we're working with the diode here, so we need to be sure that when we're placing it on our PCB board that we need to have the orientation of the diode correctly. If you need to learn more about diodes and diode orientation, you can check out our blog post on diodes. The link will be in the description below. Or you could visit motbots.com and just search diodes. So you can see this is how the diode looks after placing it through the through holes of the PCB board. Okay, now you can see on your screen I have resistor R1 highlighted. This is the next component we're going to be working with. So I'm going to remove resistor R1 from the breadboard, and we're going to transfer it to the PCB board, and we're going to place it just exactly like we did on the breadboard. We're just recreating what we had on the breadboard onto this tiny PCB board. Just take your time and make sure you're following the schematics exactly and placing your components on the PC board in their correct orientations exactly like they were on the breadboard. Okay, now I've highlighted the section of the schematic in green where we have currently placed our items onto the circuit board. We've got the diode and we have it in correct orientation. We're considering where these pads are that you can see on the PCB board to be the positive probe side. This will be exactly where the positive probe will be later. And we have the anode of the diode facing in that direction and the cathode of the diode facing in the opposite direction. And what we'll do is we'll make the connection with the resistor to the cathode of the diode as shown in the schematic later when we start soldering the components together. So if we consider the shiny pads that don't have holes through them on the PCB board as our positive probe side, as in the schematic shown, then we can trace from that end where the lead of the diode is pointing towards that end and the anode facing towards that direction, and then the cathode of the diode coming through the opposite end, and then from there we will connect the resistor to the cathode end of the diode just as we have shown in the schematic, and then the other end of the resistor will be connected to the negative probe of the circuit tester as shown in the schematic. So again, we can see the marks that I made earlier for where I wanted the diodes to be placed at on the PCB board, and I'm just going to remark them again. So here on the schematic here, I have the white LED highlighted in the schematic, and that's the next component we're going to be transferring from the breadboard circuit to our PCB board. And what I need to do now is just straighten out the leads of the LED, and then we'll place it in the through holes of the PCB board, making sure that we have the correct orientation for the LED as shown in the schematic. Okay, next on the schematic I have the portion of the positive probe side of our schematic highlighted in yellow. And looking at the schematic, we can see that we have the anode of the diode D1 facing towards the positive test probe. And I'm saying positive. I'm just referencing it as the positive end, although the circuit tester schematic shows that the test probe could be either positive or negative, and that is true, but I'm just referencing it as the positive test probe end to make explanation a little easier, and that's why I placed the probe in the schematic as the color red for the purposes of explanation, that it makes explaining easier. So again, we have the anode of the diode D1 in the direction of the positive test probe, and then from D1 we go to resistor R1, and then from resistor R1 we go to the white LED, the anode of the white LED. We have to make sure that we also have the LED in the correct orientation. It is also a diode. And then we need to have the cathode of the white LED facing towards the negative probe side, or the black probe or alligator clip in the schematic shown. Okay, now referencing the schematic again, I have the diode D2 highlighted in yellow, and that's the next component we're going to transfer from the breadboard to the PCB board. We're just going through the same process as we did with the other side of the schematic from D1, R1, and the white LED. Now we need to do the same process for D2, R2, and the red LED. I need to straighten the leads of the diode, and that way I can fit the diode onto my PCB board. So here's a close look at what we've done so far and how we've placed the components that we have right now on the PCB board. Okay, next we're going to be looking at resistor R2 as highlighted in yellow on the schematic shown on your screen. I've already placed resistor R2 onto the PCB board, as you can see here. And next we'll be looking at the red LED as highlighted on the schematic shown on your screen. You can see that I've already transferred the red LED to the PCB board from the breadboard. And now all we just need to do is solder the components to the PCB board. I've removed the white and red LEDs from the board for right now to make soldering easier, because the LEDs were kind of in the way, so I had to remove them in order to solder the resistors and the diodes first. We just need to be sure that we're soldering the components in a way that they are connected in sequence as shown in the schematics. They need to be connected exactly like they were on the breadboard and as shown on the schematic that's provided in the description below. Or you can visit motbots.com, and that link will be provided in the description below for this project as well. Okay, you can see that I've written the letters W and R onto the board, and that is just reference where I need the white and red LEDs to go, and the plus and minus is where I need the anode of the white cathode to be, that's the plus, and where I need the cathode of the red LED to be, and that is the minus symbol. Okay, looking at the schematic, you can see that I've highlighted 2 points in green, one being the cathode of diode D1 and the other being the anode of diode D2. And that's where I've marked these black marks on the PCB board, and that's where the connections between the diodes and the resistors need to be soldered at on the board. So I'm just going to twist over the lead of diode D2 and the lead of resistor R2 over. That is the R side marked on the board, so that's the red LED side. So that's the point that we're working at where we need to make the connection between the diode D2 and the resistor R2 together. And I'll just snip off the excess leads. Next, I'm going to bend the leads of diode D1 and resistor R1 together, and I'll solder those leads together, making the connection for those to the point that I referenced on the schematic previously. Okay, now we have our diodes and resistors connected at the points that I highlighted earlier on the schematic in green. Next, as you can see on the schematic on your screen, I've highlighted the point in green on the circuit where resistor R1 and the white LED meet. So we need to make the connection between resistor R1 and the anode in of the white LED together. So I will just bend the lead of the anode of the white LED over towards the lead of the resistor. Now I just need to snip off the excess on the leads. Now I need to solder the red LED to the board, and then we're going to make the connection between the red LED and resistor R2 as shown on the schematic. Referencing the schematic again, you can see that I've highlighted in green where we need to make the connection between resistor R2 and the cathode of the red LED, similar to how we just did for resistor R1 and the white LED. But be sure you have the correct orientation for your red LED as shown in the schematic and exactly how we did in our breadboard prototype circuit. Again, referencing the schematic, I've highlighted the positive test probe side in yellow, and the 2 LEDs that you see sticking up on the PCB board, those are the 2 diode leads D1 and D2. So referencing this breadboard prototype circuit, we've placed in diode D1 coming from the positive test probe side. We're kind of looking at it in a mirror image onto the PCB board because the white LED is on the right and the red LED is on the left. But the reason for that is because I needed the LEDs to come out the opposite side of where the components are on the PCB. So it might look a little confusing that the LEDs look switched around, but I assure you that all the components are placed on the PCB board exactly like we had them on the breadboard. So here's going to be our positive test probe, this paper clip here. It's your typical 2-inch paper clip. And what we're going to do is we're going to have it placed where the pads are on the PCB board here. But first we need to straighten out the paper clip so we can have it nice and straight as we can get it. And that will be our probe. It'll be a nice, fairly sturdy probe for whatever we need to probe or use it for. But the benefit of having this paperclip as a probe is that we can use it on smaller circuits too, unlike your typical automotive circuit testers, which usually have much bigger and thicker test probes. So what we need to do first is we need to remove some of this clear plastic coating that's on this paper clip. I don't know if you can see it. You can just see it here. But what we need to do is just remove enough to have the probe end exposed. If we don't take this off, we're not going to be able to touch anywhere on a circuit and get a good connection to be able to have our circuit tester work properly. So we need to remove this plastic coating. We don't need to remove the whole thing. I'm just going to make a score back far enough, maybe an inch or so, just to get it exposed. And this will be our probe end. This is the end that's going to poke through the hole that we made at the very round tip of the cigar tube. What I did here is I bent or made this kind of offset bend at the end of the paper clip. This is the side that we just removed the plastic coating, the end that will poke out the hole at the end of the cigar tube later. The reason why I made this offset bend is because the way that this paper clip is placed onto the pads of the board, the LEDs are centered on the tube, but this probe is offset from the center, and I need to get the end of the probe offset or centered back towards the centered hole at the end of the tube. So the only reason why I made this bend is so that I can get the end of the paper clip through the end of the tube through the hole, and for it to be nice and straight when it protrudes at the end. So you can see this is where we're going to place the paper clip on these pads on the PCB board. But just like I did earlier, we need to remove the plastic coating on this other end of the paper clip. That way we can have that end exposed to be able to solder it to the pads on the PCB board. So now that we have it removed, we can now easily solder that in and make a good connection to the PCB board. We can solder it easily onto the pads. I'm going to place it underneath the leads of the diodes that I still have not clipped off yet. First, I need to tin the pads of the PCB board in order to be able to easily solder the paperclip to the board. And I'll also tin the exposed end of the paperclip that we're going to place on those pads. That way it makes it easier to make that connection between the tinned pads and the tinned end of the paperclip. Now that the paperclip is soldered to the pads of the board, this again is going to be our positive probe end, so we need to make the connection of the leads of the two diodes, diode D1 and diode D2, to that paperclip or positive probe. So here you can see that we have our paperclip probe, the positive probe soldered to our board, and we also have the two diode leads soldered to the probe. This is the positive probe end as we saw earlier on the schematic. So as you can see here on the schematic, I've highlighted the negative probe side of the circuit in green, and the two leads that we see here on the PCB board are the cathode lead of the white LED and the anode lead of the red LED that both need to be connected to the negative probe side. So what I just did is moved the two leads to two separate through holes that are next to each other in order to make the connection of those two leads easier. So this lead right here is the anode of the red LED. And we can see where the two leads of those LEDs come out, and I have them touching each other here. And then I'll make a connection with a black wire later that will be the lead wire of the wire that's going to connect to the alligator clip later. So this is the point where the two LED leads meet and the alligator wire probe meets at the point highlighted in green on the schematic. So now I just need to solder the cathode of the white LED and the anode of the red LED together. I'm going to use an 18 gauge wire. I'm going to use a black wire for the negative probe lead, the wire that's going to connect to our alligator clip later. So all we need to do is just cut about a 3-foot long piece of this black wire, and then we need to strip the end of the wire. I'm going to now tin the wire end that we just stripped. Now I'm going to solder this end to where we soldered the LED leads together just previously. This is the point on the circuit where our negative lead of our test probe is at. So now we have our negative lead for our negative test probe connected. We have our positive paperclip probe connected and all of our components connected. Now I just need to strip the other end of the black wire off and get it connected to the alligator clip. But first, let's go ahead and test this out and see that it's working. Here is a 9-volt battery. I just need to take the paperclip test probe and touch one of the terminals of the battery. Here I'm touching the negative terminal of the battery first, and then I'm taking the exposed wire end of the black wire and touching the positive terminal, and we see the red LED lights up. So that means that we have positive ground, and if I switch the two probes around, the white LED lights up, and that means that we have negative ground. So at this point, we have all of our components and we have our probes connected to our PCB board. And all we need to do in the next video is attach our alligator clip at the other end of the black wire, place everything into the cigar tube, and we'll have a working cigar tube circuit tester done in video part 2 for the cigar tube circuit tester. So I hope to see you in the next video. Remember, keep at it and stay motivated. And thanks for watching.